everyone. Thanks for joining me today. As you may have noticed, in the past year, Node has shipped some new features to improve CommonJS and ESM interoperability and to make maintaining packages easier. So today I will talk a bit about how to ship Node packages in a modern way in 2025. So a little bit about myself. I'm Joyee. I work at a consultancy called Igalia, and a lot of my work has been sponsored by Bloomberg. I'm a member of the Node Technical Steering Committee and a VA committer. And in the past year, I've been trying to improve module loading in Node, among other things. Now, before we talk about how to ship Node.js packages in 2025, let's see how they have been shipped up until now. This is the data I took from a project called NPN ESM versus CJS from Tejas. It surveys thousands of high-impact packages and classifies them based on module format. Here, ESM means the package is written in ESM and also directly shipped as ESM. Dual means is written in ESM, but it ships two copies, both ESM and the transpile CommonJS version. And both copies can be loaded by the runtime depending on what kind of module is loading that package. Then there is also faux ESM, which means the package is written in ESM, but only the transpile CommonJS version is supposed to be loaded by the runtime. Finally, there's the good old CommonJS. Those are packages still written in and shipped as CommonJS. So as you can see here, after 5 years since ESN was stabilizing Node, the majority of the high-impact packages are still just CommonJS. The migration is slowly happening. Packages written in ESM is on the rise, but the majority of them are not even directly shipped as ESM. The most popular way to ship ESN actually is to ship dual. Put it the other way, more than 80% of the high-impact packages are still shipping CommonJS and likely effectively run as CommonJS in Node. So the reality in the ecosystem has been that when people write ESM, what they see isn't typically what gets run. Why were the packages reluctant to just ship ESN as is? Because for years, that means breaking compatibility for users running CommonJS because require could not load ESM. And because most code was still run as CommonJS effectively, so no matter how they were written originally, so breaking compatibility with them means losing quite a lot of reach. So here we have an example. When CommonJS code tried to load an ESM, like logger that I'm just here, it will throw error require ESM. This happened to both code written in CommonJS and to ESM code transpiled to CommonJS, which was done by Mini Chain. Now, CommonJS code are capable of loading ESM using the dynamic import, but that returns a promise and would only work in asynchronous code, which tended to be a big deal breaker. It gets even more confusing when many packages, frameworks, and tools transpile ESM to CommonJS magically to support it, which can sometimes make things worse. Like here, like a framework tries to support ESM users who are supposed to export a handler for the framework to load, but it also wishes to support CommonJS that need to import pieces of the framework to do the job. Then, well, it's typical for a framework to ship itself as CommonJS, and transpile the ESM user handlers before loading them from CommonJS. This is usually magically done under the hood, and developers only see ESM in their own handler code. But when the handler gets run, Node only sees the transpiled CommonJS. Now, if the transpiled code attempt to load external ESM using require, developers will start to see error require ESM from their code, even though it was written in the ESM format and had no require in the source, which would be very confusing. If you search for error require ESM, you can see a lot of people struggling with this on the internet. This also creates a vicious loop. The more code in the wild are run in CommonJS via rich translation, the more users and transitive dependencies also have to stick to CommonJS as an execution format. And they need to deal with the surprises from missing the transpilation step of some part of the codebase. Another workaround that packages do was to ship 2 copies of itself that supply ESM to ESM, CommonJS to CommonJS, using conditional exports. One of the most obvious side effects is that it doubles the size of no modules. So this just doubled. Apart from the duplication, dual packages are difficult to get right. For example, if you have a ESM consumer A that loads 2 different dependencies, one in CommonJS B and one in ESMD, and they in turn loads the same dual package C via 2 different paths, well, you will end up with 2 versions of that dual package C in the same graph. And not every package is set up correctly to expect 2 versions of itself in the same graph. This can lead to some very tricky bugs if the package has some global state that is not supposed to be duplicated. Then package maintainers entered into a pick your poison situation. If they ship ESM, CommonJS users get broken, and it will reduce their reach and popularity because, well, that's still the majority of the code getting executed effectively, even with transpilation. If they stick to CommonJS, tree shaking will be less effective with them. They can be run in browsers directly, and they need to deal with issues when their external dependencies decide to migrate to ESM only. If they ship faux ESM, it also needs to deal with the dependency issues, and there's the overhead of setting up transpilation, which can be annoying. If they ship both, then on top of the transpilation overhead, it's difficult to get right, and it blows the node modules folder. And all these just made ESN a less desirable shipping format. Most packages ended up shipping some form of CommonJS, like what we saw before. Only 10% or so of the high-impact packages actually just directly ship ESM. And this likely is an overestimate because these statistics includes the older version of these packages that maybe were still shipping CommonJS, which still have been downloaded more than the newer version of ESM of itself in practice. It also demotivated the adoption of ESN, and many people started to get tired of the ESN migration. They complained that, well, it has broken too many things for little games. Now, what if ESM can be loaded by require? Most of these problems would go away. So ESM and dual package would become obsolete because packages can just ship ESM to all users directly. There's no need for an extra CommonJS copy to maintain compatibility. JavaScript packages can just ship in the format in which they are authored. It will only come down to a choice between writing ESM or CommonJS, and it's up to the preference of the package author. And most authors these days prefer to write ESM for no code anyway. Users can do incremental upgrades for different parts of the code base and gradually uplift themselves into ESN instead of having to go into a big bang migration. That can be very important when the code base is huge with multiple people working on it. And with this, we can break the vicious loop of CommonJS dependencies. But ever since ESM became stable in Node in 2020, for many years, ESM was not requireable, and the community had come to assume that. When you look into the Node documentation about this, it had been claiming that it was not going to happen because ESN is async, require is synchronous. Well, at least up until recently. There were some attempts to implement require ESM in 2019, which would have allowed running the asynchronous top-level await from synchronous require. And therefore, the implementation was unsafe. That could crash, so it was abandoned. People who were involved in the development of ESN in Node had some debate about the theoretical edge cases, but it remained a niche knowledge. Then time went by, and people stopped trying. So most people who were not involved in ESN, like myself before, just believed that it was not supposed to be supposed to be happening. That it was not possible by design. Around late 2023, I was looking into a leak, and I ended up looking into some VA implementation of the ESM as part of the investigation. And I discovered by chance that what the node documentation stated was actually not true, or at least partially untrue. This is a simplified version of what VA had internally back then, to give you an idea. So VA would actually just evaluate the module synchronously if neither the ESM nor its dependencies had top-level weight. In that case, it would just return a promise resolved to undefined synchronously. And this was not invented by VA. This semantics was actually mandated by the language specification. So this means, as a host, it would be fairly straightforward to, at least theoretically straightforward, to implement something like this. This is pseudocode. In reality, this needs access to native VA APIs, but the gist of this is to implement require ESM. Node can just fetch the module graph and link them synchronously first. That part is up to the host, so Node can make it synchronous. If it has top-level weight, it can just throw. VA already implemented this API for checking top-level weight in the graph because servers workers on the internet, on the web, also have these semantics since 2020. So throwing at the presence of top-level weight wasn't even an unorthodox concept on the web. We also did a bit of survey, and it turned out only 6 out of the 5,000 high-impact packages had top-level weight, and 5 of them only added it during migration to ESM for convenience, and they had alternative not to do this. So this would mean that most package maintainers would not find themselves constrained by this during a migration because a top-level weight already was mostly a thing for applications and scripts, or it was mostly a thing for code that only import other modules, but was not supposed to be imported by other people. And if the module does not contain top-level weight, the evaluation can must synchronously return a fulfilled promise resolved to undefined as required by the language specification. And at that point, require could just return a populated namespace. So after I stumbled upon this interesting rabbit hole, so to speak, sometime later, I got support from Bloomberg to restart the implementation. And the first iteration was released in 22.0.0 behind the flag. It was then unflagged in 23, then backported to 22.12, and finally backported to 20.19. So by now, all active LTS releases of nodes support require ESM. So that means at this point in time in 2025, okay. Thank you. So that means at this point in time in 2025, if a package does not need to support insecure Node.js versions that have already reached random 5, they can start counting on the existence of this feature to ship ESM directly and just forget about the dual shipping mess. When I was iterating on the feature, a lot of package maintainers reached out to me to provide feedback because this was the last blocker for them to ship ESM only. And after the backport to 20.19 was released, many popular packages have started the migration. But, and there's always a but, not everyone has gotten the notice, apparently. And ChatGPT neither did many of the LLMs that I've tried. If you go ask them how do you ship a node package written in ESM that both CommonJS and ESM users can load, they will tell you to build 2 artifacts and blow your node modules at the first try anyway. And that's a problem because there's an increasing amount of code being generated by these tools, often at the request of people who are new to the practice. So this is what I'm here for, to spread the word about the right way to ship an ESM package in 2025. So let's start with the formats that will benefit the most from shipping ESM only, dual and faux ESM packages, because these were already written in ESM. They were just transpiling their code to CommonJS and shipping it for backwards compatibility. Now, to drop the transpiled CommonJS copy in their distributions, we need to first prepare the ESM code. So first, make sure there's no top-level way for code that's loaded by external users. It does not matter if the code being updated is not meant to be shared to other people. Like if it's just test, that can use top-level way just fine. This usually is not a concern for dual or faux ESM packages because whatever tools that they use don't usually support transpiling top-level way to CommonJS in the first place, so they probably do not have that anyway. The more common source of problems would be these extensionless imports, which only would have worked when the import statements gets transpiled into require and executed as CommonJS, because no requires all paths being imported in real ESM to be full paths. Like here, instead of lib index, you need to have libindex.js and include the .js extension, or instead of using libdir and count on Node to look up the index.js for you, which is not going to happen for ESM. You need to spell it out. For TypeScript packages that were transpiled to JavaScript for shipping, it was common for them to omit the extension when doing imports into source code so that at build time it resolves to .ts in tools, but at runtime the code compiled to CommonJS can resolve to .js via require. However, as we talked about earlier, this will not work if the transpilation target was ESM, because no need the full path. So to address this use case, TypeScript 5.7 introduced a new option called rewrite relative import extensions. With this option, the TypeScript source code can just write the full path with the .ts extension in the import statements, which is recognized by tools when processing the files for type checking. But when the code gets transpiled into JavaScript, TypeScript compiles that the new option, TypeScript compiler that support the new option would replace the .ts extension with .js in the emitted file, so that the ESM code generated will have the full path and work correctly in Node. Now, when the source code is ready, let's take a look at the package.json. Here we have one common pattern, supplying CommonJS to CommonJS via the require export condition, and ESM to ESM via the import export condition, and default to ESM for other environments. So this is prone to the dual package hazard, as mentioned before, because two copies of the same package can end up in the same graph via both require and import. So the package needs to make sure that either the states can be duplicated or shared states live only in one subgraph to avoid the problem of having two copies of the global state when there is supposed to be only one. But this is a very popular pattern, so let's start with that. Because now both require and import can load ESM just fine. There's no need to split the condition, and we can simply merge it into one, which is much simpler. Well, this is not really breaking user code, or most user code will just continue to function without changes. This changes the no versions that the package support, and it drops support for older end-of-life no versions. So you will need to update the engines field, and it's common practice for packages to bump a major version when they do so. If a package is already requiring these versions of Node because anything older than this are the end of life in 2025, then they are already good. Another common pattern of dual packages is to always supply the CommonJS version to both require and import in Node, and to avoid having two copies of the same package in the same graph, which is indicated using the Node export condition here. In other environments, like when being bundled for the browser, they supply the ESM version, which is indicated using the default export condition here. And similar to the previous pattern, we can just get rid of the split path and change the engines field to ship ESM directly, and it's now nicely simplified. There might be some other package-specific migration to do, but anyway, after updating the code and package.json and maybe adding some tests and update the two chain configurations, a dual package can then just delete the transpile to CommonJS build step, and the package would be slimmed down by only shipping ESM assets. So one of the latest examples would be Storybook 10, which shed off 15% of its weight by dropping the dual distribution and going ESM only. And it could have reached like something closer to 50% for minified code, but they decided to ship unminified code for developer experience. Now, another type of package that can be more easily migrated is faux ESM. So their code is already written in ESM. They just always only supply the transpile CommonJS version to be run in Node. Usually, faux ESM packages do not have the type fill in package.json. They rely on the fact that when the type fill is missing, Node would just treat all .js files as CommonJS. If they also ship their original ESM for bundlers to perform better tree shaking, they might also have a top-level module field, but that part is only used at build time. For runtime, they usually specify the legacy main field for Node to look up the entry point. So to migrate faux ESM to ESM only, because they usually have ESM in .js files directly, which some bundlers recognize but Node does not, we need to add the type field explicitly to tell Node to treat them as ESM. Then the main field can be updated to point to the ESM files instead, and we can update the engines field like how we updated it for dual packages. Or we can be a bit more aggressive. If the package no longer needs to support very ancient bundlers, it can just stop using the module and main field. Instead, go directly with the exports condition because most modern bundlers support that. It also avoids leaking internal files to users, which can be useful in many cases, though this may also require bumping the major version of a package. So we covered two types of packages that were already written in ESM. For those packages, dropping the CommonJS build is almost always a win, a no-brainer. Now let's get to the more debatable type packages that are still written in CommonJS. So here, let's assume that a maintainer has already considered the pros and cons of the migration, and they've decided that for their package, migrating to ESM would be a win. The first thing to do is to update package.json. In this case, it's typical to update all shipped .js files to ESM. Then it's necessary to specify the type field in the package.json as module so that .js files get treated as ESM. If some files have to stay in CommonJS for whatever reason, they can use the .cjs extension. Or if they need to do it gradually, they can convert it on a file-by-file basis. The migrated files can use the .mjs extension, and the pending files can stay as .js. If the distribution still needs to be processed by other tools like a TypeScript compiler, they can configure the tools that they use to emit the migrated files to emit .njs, like using the .nts extension. When the migration is done, they can just flip the type field and rename the migrated .mjs files to .js and then be done with it. And for the imports is mostly straightforward. Just be aware that built-ins must be prefixed with the no column prefix. Here we have, for example, here we use the no column fs instead of just fs in ESM. And paths must be fully extended, as we mentioned earlier. And if you have been relying on required domain, in your version of Node, we can use import.meta.main. If you need file name or dir name, the current active LTS releases also have direct equivalents on the import meta object. Now, we're getting into the trickier part, the exports. If a CommonJS version only just assigned properties to the exports object, that's straightforward. Just use a named export in the ESM version. Or if you need different names, use the export as syntax. If the CommonJS version only export by reassigning module.export directly, in the ESM version, they can use the export default syntax or use the export something as default syntax. Now, what if we have both? default and named exports, things get trickier. For example, here the CommonJS module provides both the logger class as a default export and a static log function as a named export. To do that, it reassigns module that exports first for the default export, and it assigns module that exports that log explicitly again to interoperate correctly with ESM importers. And with this format, the ESM and CommonJS users can get both using relatively similar syntax. Now, if the package migrates to ESM, then to maintain compatibility with ESM user code, it should use the export default for the logger class and use a named export for the static log function. But this will break the CommonJS users because according to the ECMAScript specification, the two are separate in ESM. So require ESM, which works like the synchronous equivalent of the dynamic import and returns the namespace object, will have to place the default and named exports separately, like what would be returned by dynamic import. Then the CommonJS user code would have to unwrap it from the default property of the namespace object returned by require ESM, which will make ESM migration a breaking change for them. This will again make ESM migration a difficult choice. So to deal with this discrepancy, Node supports this special module that exports string named export. So this is recognized by Node when ESM is loaded by require. When the value is exported using this string name module that exports, like the logger class here, Node will return them instead of the entire namespace object from require ESM. So using this, a CommonJS module that has both named and default exports can migrate to ESM without breaking the code for any of their users. Another blocker that people reported for the migration was that the module may have to do some sort of synchronous dynamic loading at the top level. One common use case that people mentioned was to optionally load some Node built-ins in code that's supposed to be also bundled for browsers. It can be achieved with the equivalent of something like this in UND, where it first checks whether it is in CommonJS, and if it is, load, for example, Node::OS would require, and maybe do some system-specific tuning with it. Now, when the code is shipped as ESM, it can no longer use require to synchronously load a built-in, and would have to resort to dynamic import, which is asynchronous, and it needs to involve await if it's done at the top level. This may be problematic if the code path is part of a synchronous API, or if the module wants to be compatible with CommonJS consumers, because only modules without top-level await can be loaded by require. For this use case, Node introduced a method in the process object called getBuiltinModule. So as you can see here, we can use it to re-implement what the first CommonJS snippet is trying to do synchronously as some sort of require, but only for built-ins, and is available in ESM in Node. And if what the module needs is to synchronously and dynamically load a non-built-in, now there's a TC39 stage 1 proposal to introduce dynamic synchronous import to the language, but that will take a while to materialize, if it ever materializes. For now, an ESM in Node can use create require from the module built-in to create a synchronous module loader. So this has been existing in Node for quite some time now. And you can use it as a working alternative to the TC39 proposal. If what you need to load is known to be ESM, but optional, you can even use the process.features object to detect whether the current Node version supports require ESM and do some fallbacks if it doesn't. So we have covered the common patterns to migrate different types of packages to ship as ESM only. There are still more details and other less common patterns, of course. In the Node organization, we have been collecting them and trying to write an official guide with examples about how to ship packages in a modern way. And hopefully this would send a notice to the AI tools so that they will stop telling people to upload their packages. And hopefully this can help new maintainers to stay up to date with the best practices. So if you want to contribute, this is a link to the repository. So thanks for joining me. I hope the talk is helpful.